Hello everyone, my name is Ankit Verma and today we are learning linear regression and logistic regression. Here we are having a diagram in which we are having x-axis and the y-axis. On x-axis we are having independent variable and on y-axis we are having dependent variable. Independent variable means which are independent, just like experience. On the other side, we are having dependent variable which is salary. So our experience is increasing, that is independent. But because of increasing experience, our salary is also increasing. So salary is depending upon experience. More experience, more salary. So here is a positive relation between the salary and experience. This is the example of linear regression. There is one more diagram in which we are having x-axis and the y-axis. On the x-axis we are having independent variable and on the y-axis we are having dependent variable. In the logistic regression we are having only two things, which is 0 and 1 or yes and no or pass and fail. So there are only two possibilities. That's why here the curve is like S shape. Just like the result of an exam can be either pass or fail. So if we are pass, that means we are on 1. If we are fail, we are on 0. Now we are learning the difference between linear regression and the logistic regression. In the linear regression, we have continuous values, just like price, age. But in the logistic regression, we have categorical values like 0, 1, yes, no. The next point is linear regression solve regression problem. Regression problem is the part of supervised learning where we have the continuous relation between dependent variable and the independent variable. Just like if the experience is growing, salary is also growing. This is the positive relation. And there is one more example. If the age of car is increasing, the price will decrease. This is the negative correlation. So these all are the continuous values which comes under the regression problem. The logistic regression solve classification problem. The classification problem is part of supervised learning in which we classify the things into two parts, just like 0 and 1 or yes and no. So here in logistic regression, we solve this classification problem and we divide into two categories. When we have two categories, this is called binary classification. And whenever if we have multiple categories, it is called multi-class classification. In linear regression, we have best fit line. Here we can see that in the linear regression diagram, there are the data points and there is a line which is going. This is not exactly going through all the data points, but some of the data points may be in between and some are nearby. So this is a straight line which is also called best fit line. This is best line because through these data points, this is the best possible way or the best possible line which can pass. In the logistic regression, we have S-curve line. Here in the diagram of logistic regression, we can see that it is forming a S. So here above we are having the 1 and below we are having 0. So this is the S-curve line. Between 0 and 1 we have the threshold value, let's say 0.5. Let's take the example of the exams. In the exam we are having 0 marks or the 100 marks. So the people who are having marks above than 50, they are pass and below than 50 they are fail. So here 50 is the threshold value. In the similar way, between 0 and 1, 0.5 is the threshold value. So the values above 0.5 will fall under the 1 category and values below zero point 0.5 will fall under the 0 category, because here we are having two solutions, 0 and 1, means pass and fail. So marks more than 50 are pass, marks less than 50 are fail. In linear regression, we use least square estimation method to find accuracy. But in the logistic regression, we use maximum likelihood estimation method to estimate accuracy. Next is, in linear regression, linear relation is required between dependent variable and independent variable. But in the logistic regression, linear relation is not required between dependent variable and independent variable. Here we can see that in linear regression, linear relation is there, and in the logistic regression, linear relation is not required. Next is, linear regression predict continuous dependent variable from independent variable, and logistic regression predict categorical dependent variable from independent variable. So here we have learned the difference between linear regression and the logistic regression. In linear regression, we work on continuous values just like 0, 1, 2, 3, 4 and so on, which can be price, age. And in logistic regression, they work on categorical values just like 0, 1, yes, no. In linear regression, they predict continuous values of dependent variable from independent variable. And in logistic regression, they predict categorical values of dependent variable from independent variable. The linear regression solve regression problem, logistic regression solve classification problem. These two problems are the part of supervised learning. In linear regression, we have best fit line, which is the best fit among the data points. And in the logistic regression, we are having S-curve line, which is falling from 0 and 1 and making a S-curve. In linear regression, to estimate accuracy, we use least square estimation method, and in logistic regression, to measure accuracy, we use maximum likelihood method. In linear regression, we have the linear regression, means a line is there between dependent and independent variable. This is required. But in logistic regression, that line is not required because that can be S-curve. So only there is one major difference, which is linear regression work for the continuous values and logistic regression work for the categorical values. And based upon that, all the differences are there. So these are the difference between linear regression and the logistic regression. That's all for today. Thank you.